Hi students, and welcome to Preliminary Chemistry and the first in the metals series of videos. In this first video we're just going to have a little bit of an overview of the importance of metals throughout history as we identify the fact that metals have been used and in fact have dominated cultural life for many thousands of years. A few important points, I guess, just to kick us off. Metals are one of the important groups of elements. They're located on the left to the center of the periodic table, and they certainly hold the greatest number of subgroups, if you like, of elements in the periodic table. A very large number of elements are metallic. Because they're elements, they are pure substances, so they have consistent properties, both chemical and physical. And they also have a very small number of valence electrons, that is, electrons in the outermost shell. As a consequence of this, they tend to form positive ions or cations. Most metals will react in chemical reactions in order to form positive ions or cations by losing their outer shell or valence electrons. The wide variety of uses that we make of metals is related to both their physical and their chemical properties, and we're going to explore these in this and future videos. What we need to do first of all is just have a quick walk through the ages of metals. As I mentioned at the beginning, metals have dominated culture over time, and that's been a consequence of two things. Firstly, the particular type of metals that were obtained was based on their reactivity. So the most unreactive ones are the ones that we find first. So the one that dominated most of prehistory, as far back as 10,000 BC, is gold. Gold was very important to the Egyptians, and most of the metallurgy, or the discovery and use of metals, happened in, or at least originated in, the Middle East and across the north of Africa. And these nations dominated, not only they were in the right place for the mining of these particular metals, but they found them and they knew what to do with them, and they formed the basis of their cultures. Obviously, we still use gold today for jewelry, not quite in as extravagant a way as the ancient Egyptians, but it's no less valuable to us now as it was to them. The low reactivity of gold made it an excellent one to be finding early on because it wasn't hidden in compounds with other elements. As we progress through the ages of metals, we see that as the metal becomes more and more reactive, copper and iron and many of the metals in our modern age, such as sodium, magnesium, these metals are much more reactive and therefore are not likely to be found in their uncombined state. And so we needed to develop not only methods of identifying them, but also methods of extracting them in order to obtain pure samples of these different metals. And once we had them, to then study them and look at their properties. So you can see that the history of the ages of metals is a history of which I guess looks at how, or at least replicates the sequence of activity from low activity to high activity, being the ones that were discovered first to the ones that have been discovered most recently. We will have a look at the age of metals in a little more detail in a future video. For now, the most important thing is just to summarize a couple of those points that I just made in the previous slide. Firstly, less active metals are the ones that are most likely to be uncombined, so therefore to be found in what we call their native state. Gold and silver, two obvious ones that fit this bill, but some copper can also be found in its native state. Now, copper does occur as an compound as well, and an ore, but it can be found in its native state. The more active metals are the ones that are more commonly found as economic minerals, such as ores, or as other minerals or compounds, and we'll have a look at these as we go further along. Now, the important thing about active metals is that the more active the metal, the more energy is needed for its refinement. So initially we found if the metal is found freely in the ground, then there's virtually no energy requirement in order to extract the metal. You just pick it up, basically. For ones that are low activity but form compounds, we may need to smelt them. So we just heat them in the presence of carbon, and that carbon often will remove any oxide, that oxygen from the oxides that are formed, and leaving us with the pure metal. But for those that have higher activity, we need more sophisticated methods, such as electrolysis, in order to isolate the material of the metal on its own. This activity series is something that we're going to be looking at a little bit later on in this topic, and it does affect how easily it is to extract and to even locate the metal. Just as I guess a link to reinforce what I've already said, the discovery of metals was highly linked to not only their activity but also the technological sophistication of different societies. Up until about 2,500 years before present, we had only 7 key metals that were actually known, and those were the very unreactive gold and silver and copper and low activity lead and tin that dominated the cultures back then. But as we developed more sophisticated technologies, furnaces and smelters, we were able to extract more active metals. And this has continued on as we've used electricity, as we were able to harness electricity and then use it for chemical reactions to extract more active metals like aluminium or sodium. And then finally, things like nuclear energy has also given us the ability to produce different metals like neptunium, plutonium, that we've also used in very much more recent times as we've been able to develop these different techniques. So metals over history basically are related to their activity, how easily they combine with other elements, and also the technology that's available in order to extract and isolate those metals. Thanks for watching.